This class is actually called plane geometry, as in Plane, right? Because we're talking mainly about planes. Your marker board is a plane, your book is a plane, your piece of paper is a plane. If you take a ruler and you lay it out on your desk, if all points on that ruler are all touching at the same time, then you're on the same plane. Okay? Under your desk is not the same plane as the top of your desk. All right? The back of your paper is not the same plane as the front. So we're looking at it. If the walls of your classroom are taking as illustrations of planes, what is the intersection of two planes? Look in this classroom. Where's the intersection? It's going to be where the ceiling meets the wall, where the floor meets the wall, or where the corner meets the wall. Those are going to be different planes. The wall is one plane, the ceiling is one, the floor is one, that wall's another one, that wall's another one, and the wall you can't see behind you. So we're looking at the planes and the points on that plane. And we're going to look at how they relate to each other one step at a time. So this course will be called plane geometry. No work for section 1.1. Move to 1.2, the line. Note in this classroom cell illustration of a straight line. Find some straight lines in here. Well, since I'm sitting in front of a graph board, there's dozens, probably thousands of lines. Every single one of these blue marks is a line across on the horizontal, up and down on the vertical. The trim of this board is a line. The edge where it meets the wall is a line. Around the poster, on the poster, over on the walls where the blocks come together. On this book itself, there are lines. Y'all know what a line is, all right? Lines, however, go in both directions. If there's an arrow, that means they keep going. If there's a point, it means that it's from this point to this point. If there's one point and it keeps going, it's a ray. We'll get to that later. So note in the classroom several illustrations of the straight line. Mention other illustrations outside. So you can answer these 5 questions on a piece of paper and turn that in as 1.2 geometry. Or if you want to do all the work for this week and turn it all in on one piece of paper and save your paper, save a tree, do that. All right? Tear a piece of paper, make the rough edge straight. Through a point P represented by a dot, draw 5 straight lines. How many straight lines can be drawn through P? You can draw as many lines as you want. It's just going to get kind of crowded. All right? Select another point and call it Q. Draw 5 straight lines, each ending in Q. Now if you look, they have A and B, and they have 1, 2, 3. And it asks, which is the shortest path? You look at it, you answer. And of course, you should have learned a long time ago, the shortest path is the one that's the straightest. It's going to get you there, all right? A straight line has the same direction throughout its length. Unless otherwise stated, the word line means straight line, all right? Then you have a think it through. These are just extra credit they want to get you thinking. Why do we cut corners when in a hurry instead of going around the corners? Again, it takes longer to go all the way there and back again than it does to go across the diagonal. To cut the corners saves time. Keep going to the back. We have some more work for exercise 2. Tells you to draw some points, and it says 2 points determine a straight line. So unless it has arrows, a line is going to go from one point to the other point, and you can measure the distance between. We have a drawing here. We have principle 2. Only one straight line can be drawn between 2 points. If I'm going from where I am to that door, there's only one straight line from this point to that point. All right, one straight line. Now, if I'm going to go to that corner, that's a different straight line. To that corner, that's a different one. But there's only one going through here. That was one of your principles. Principle 3, 2 straight lines can intersect at only one point. So if I have 2 lines and they're going to cross or intersect, there's only one point where they hit. Nowhere else. Unless they're the same line. If they're the same line, then all their points are going to be the same. That's your principle 2. They have some more think it throughs. You don't have to write these down. You can think about them. What you do need to write is exercise 1.2. There are 3 questions for you. You want to do that. If you want extra credit, do the think it throughs. Section 1.3, the line segment. A line segment means it's a measured part of a line. Okay? The lines we have studied so far have represented lines of limited length. In drawing them, we used only a limited portion of the line. A limited portion of a line is called a line segment. That means it doesn't keep on going all the way to the right and all the way to the left. It's a segment. A line segment, or simply a segment. So, we have this example here, A and B. Between point A and point B is a line segment. The line itself with the arrows is a line. It keeps going in both directions. A ray has a specific point for A, but it keeps going past point B. A to B is a segment. A going on and on and on is a ray. Again, A to B is a segment, and G here is a segment. Equal segments. Two line segments are equal when their endpoints can be made to coincide. That means when we measure them, they're going to be exactly the same distance from point 1 to point 2. All right? Midpoint. A line segment is bisected by a point when it is divided into two equal points. So if you find the exact middle of a line segment, that gives you the midpoint. So C is the midpoint of A to B. So what does that tell me about AC and CB? That they're equal. If this is the exact half, then this side is going to measure and equal this one. So if I have an apple and I cut it exactly down the middle, both sides are going to be the same. Same thing with this line segment. Trisection points. A line segment is trisected when 2 points divided into 3 equal parts. All right? So that's when we take it and we divide it into thirds. And it's trisected. They can usually use a compass for that. And we have some of those in our classroom. Now you have some example of some work you can do. 1.3a. Draw lines of the following length. 3 inches, 2.5 inches, 1 7/8 inches, 3 3/4 inches. Again, there are rulers, there are compasses, there are protractors right here in the classroom. Draw several lines in different positions and of different lengths. So I won't read these questions because they're pretty self-explanatory. And as you're doing it, if you have a question, ask Miss Tracy. All right? So moving on. An algebraic equation can be used to locate points on a line. And you've already had Algebra 1, and you've already had pre-algebra, so you should know how to work these simple problems. Divide a 4-inch line into 2 parts, so that one part is 1.5 inches longer than the others. Find the length of each part by the use of the equation. Basically, x is the first part, which is 1 1/4 inches. So x plus 1.5 is the second part. So basically, we can set up a mathematical equation for how we can figure out what each of these points are. A to C, and then of course we're going to have something between here. Accurately locate the division point in the line segment and mark the 2 segments. C is the division point. From A to C is 1 1/4. All right? And from C to B is 2 3/4. Because we knew we took the whole thing and took 1/3 of it out for here and 2/3 of it left for this part. If a 1-inch line is to represent an 8-foot line, determine the length of a line that represents 16 feet. So if 1 inch gives you 8 feet, what size will give you 16? You set up a proportion, okay? We don't know what this one's going to be. So we're going to have 1 over 8 equals x over 16. Well, notice 8 doubled. So basically you can cross multiply. 1 times 16 equals 8 times x. So let's do that on the board. You have 1 inch is going to equal 16 feet. So we want to know how many inches is going to, 1 inch equals 8 feet. So how many inches is going to give us 16 feet? Set up a proportion. 1 to 8 is equal to the unknown to 16. Okay? 1 inch is 8 feet. So how many inches will be 16 feet? Cross multiply. 1 times 16 equals 8 times x. Now you just have a regular algebra problem. 8x equals 16. How do I solve that? Divide by 8. So x is equal to 2. So I know 1 inch equals 8 feet, so 2 inches is going to equal 16 feet. So now they give you some sample problems using these skills. 1.3b on page 6. Answer these on your own paper. Make sure you put your name on it. Make sure you label it. Make sure you show your work. If I just find answers there, I'm going to think someone else did your work, or you copied off someone else's paper and you're going to get a 0. So show me your work. You can miss them all and show me your work and still pass. You can get them all right and not show your work and fail. So you need to show your work. All right? And then we're going to move on. There's some more practice. It says construct a line to the sum of the two given. All right? So basically you would use your ruler and measure them. And then on your own paper you could draw your own. Because it says, use a straight edge to draw a working line of a sufficient length. Open your compass to the length of A and mark it off on your line with the point of your compass on the end point. So you draw a line, you get a compass, you open it up, open up your compass from here to here, and then put it on your paper in the same spot and make your little line. All right? Then it says open your compass at the length of B and mark it off on your working line. You now have a line segment equal to the sum of the lengths of A and B. Then they're going to have you do some things where you get to draw. Any questions? You're just drawing some lines and some line segments using a compass. The way you use the compass is you put the pencil in the end, you open it to the amount that you want, put the point on the point, and then use it. And I have in the classroom, if students have not messed with it, a big one that actually works on the board. So I will go get it if it has it.